Today we will learn about the following important concepts related to numbers: factors, multiples, prime numbers, composite numbers, even and odd numbers, common factors, common multiples, and co-prime numbers. Here we see 6 sticks. If we have to divide them equally between the two groups, then how will we do it? We have to divide 6 by 2. On dividing, we get 3 as quotient and the remainder is 0. From this, we get to know that each group gets 3 sticks. Remainder 0 has a great importance. Remainder 0 indicates that the number 2 is the exact divisor of number 6. Exact divisor of any number is called the factor of that number. Moreover, dividing 6 by either 1, 3 or 6 also results in remainder 0, which means along with 2, 1, 3 and 6 are also the factors of 6. 4 and 5 are not factors of 6. You know the reason? Think about it. It's easy because 6 is not divisible by them, which means the remainder is not 0. We express factors as multiples. Suppose 6 sticks are divided into 2 groups with 3 sticks in each group, then we express it as 6 is equal to 2 multiplied by 3. Similarly, if 6 sticks are divided into 3 groups with 2 sticks in each group, then it is expressed as 6 is equal to 3 multiplied by 2. Similarly, we express 6 as 6 multiplied by 1 and 1 multiplied by 6. Number 6 is a multiple of number 2. This is because 6 is divisible by 2. Similarly, 6 is also divisible by 3. Therefore, number 6 is also a multiple of 3. Look at this. There are 7 sticks. Can we divide it into equal groups? Think about it. Let me tell you, we can consider one stick as a group and 7 such groups can be formed from it, or we can form one group of 7 sticks. This is because 7 is only divisible by 1 and 7. Therefore, we can say that number 7 has only 2 factors. First one is 1 and the second one is the number itself. The number having only 2 factors, 1 and number itself has no other factors, is called a prime number. On the contrary, there are numbers which have more than 2 factors. For example, if we take 8 sticks, we can divide them equally in groups of 1, 2, 4 or 8. This is because 8 is divisible by 1, 2, 4 and 8, which means 1, 2, 4 and 8 are the factors of 8. The number having more than 2 factors is called a composite number. Now let's divide even numbers such as 2, 4, 6, 8, 10, etc. by 2. Do you always get 0 as remainder? Yes, you always get 0 as remainder. What do you understand by this? Think about it. You got it right. 2 is a factor of every even number. Let's divide odd numbers such as 1, 3, 5, 7, 9, etc. by 2. Do you always get 0 as remainder? No. Upon dividing odd numbers by 2, we never get 0 as remainder. What do you understand by this? You got it right. 2 can never be a factor of an odd number. Now let's look at these numbers. Let's find the factors of these numbers. Factors of 12 are 1, 2, 3, 4, 6 and 12, and factors of 15 are 1, 3, 5 and 15. If you observe, you will get to know that the numbers 1 and 3 are the common factors of both 12 and 15. This means they are common in both the lists. The factors which are common among the factors of two or more than two numbers are called common factors. The factors of the numbers 17 and 23 have only 1 as a common factor. Such numbers having only 1 as a common factor are called co-prime numbers. Let's find multiples of 4 and 6. Multiples of 4 are 4, 8, 12, 16, 20, 24, etc. And multiples of 6 are 6, 12, 18, 24, 30, etc. We can see that the numbers 12, 24, etc. are common among the multiples of both 4 and 6. The multiples which are common among the multiples of 2 or more than 2 numbers are called common multiples. Today we have learned the following important concepts related to numbers. In the next video, we will see examples related to these concepts. Today we will see the examples of the following concepts: factors, multiples, prime numbers, composite numbers, common factors, and common multiples. Example: a farmer has 12 oranges. He wants to arrange them in such a way that each row has equal number of oranges. Can you tell how the farmer has to arrange the oranges in each row? For the arrangement of oranges, it should be kept in mind that the number of oranges in each row should be equal. The farmer can keep all the oranges in a row. This arrangement is expressed in mathematical way as 12 is equal to 1 multiplied by 12. Here, 1 represents the number of rows and 12 represent the number of oranges in a row. We can divide 12 oranges equally in 2 rows. It will result in 6 oranges in each row. Therefore, we can express total number of oranges as 12 is equal to 2 multiplied by 6. Similarly, we can divide 12 oranges equally in 3 rows. That means there will be 4 oranges in each row. Therefore, the total number of oranges can be expressed as 12 is equal to 3 multiplied by 4. Similarly, we can divide 12 oranges in 4 rows, 6 rows, and 12 rows. We will express these arrangements in the following way. In order to arrange 12 oranges in a way such that each row should have equal number of oranges, we can form 1 row of 12 oranges, 2 rows of 6 oranges, 3 rows of 4 oranges, 4 rows of 3 oranges, 6 rows of 2 oranges, and 12 rows of 1 orange. These are the only possible ways to arrange them. Here, we have found the factors of 12, which are 1, 2, 3, 4, 6, and 12. Next example, the length and breadth of a rectangular field is 36 meter and 32 meter respectively. If we want to measure the length and breadth of the field with the help of rod, then what should be the length of the rod? In this example, the length and breadth of the field are 36 meter and 32 meter respectively. We have to find the length of the rod which can measure it completely. It is only possible when both the numbers 32 and 36 can be completely divided by the length of rod. That means common factor of 32 and 36 will be the length of the rod. Let's find the factors of 32 and 36. The factors of 32 are 1, 2, 4, 8, 16 and 32. Similarly, can you find the factors of 36? Think about it. You got it right. The factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18 and 36. Now, let's find the common factors of these numbers. 1, 2, 4 are common among the factors of 32 and 36. Therefore, they are common factors of 32 and 36. That means if the length of the rod is 1, 2 or 4 meters, only then it can measure the length and breadth of the rectangular field completely. Next example. Out of the following numbers, which are prime numbers and composite numbers? Number 7 can only be divided by 1 and 7, which means 1 and 7 are the only factors of 7. Since it has only two factors, 7 is a prime number. In the same manner, let's find the factors of 9, 11, 18 and 19. The factors of 9 are 1, 3 and 9. The factors of 11 are 1 and 11. The factors of 18 are 1, 2, 3, 6, 9 and 18. The factors of 19 are 1 and 19. Since 11 and 19 have only two factors, therefore, they are prime numbers like 7. Similarly, because of having more than two factors, 9 and 18 are composite numbers. Today we have seen examples of the following concepts. In the next video, we will clarify the misconceptions related to these concepts. Today we will see some misconceptions related to the following concepts: factors, multiples, prime numbers, composite number, even and odd numbers. Misconception 1. Out of the following numbers, which are prime numbers? Sometimes, odd numbers are mistaken as prime numbers, and this understanding leads to incorrect answer option 1. Similarly, 1 is also mistaken as prime number, and this leads to incorrect answer option 2. 1 is neither prime nor composite number. Since 2 is an even number, it is assumed that it is not a prime number. From the given answer, only 7, 5 and 3 are considered as prime numbers, which leads to incorrect answer option 3. The correct way is like this. Since 7, 5, 3 and 2 has only two factors, therefore, out of the given numbers, only 7, 5, 3 and 2 are prime numbers. If we talk about 9, 8, 6 and 4, they have more than two factors. Therefore, they are composite numbers. 1 is neither prime number nor composite number. That's why the correct answer is option 4. Misconception 2. Out of the following, which statement is correct for 4 multiplied by 7 is equal to 28? 1. 4 is the multiple of number 28. 2. 28 is the factor of number 4. 3. 28 is the multiple of number 7. Due to the confusion in the concept of factors and multiples, sometimes 4 is mistaken as multiple of 28 and 28 is considered as factor of 4. This misconception leads to incorrect option 1 and option 2. Multiple is the outcome of product of the factors. If we write 4 multiplied by 7 is equal to 28, which means 4 and 7 are the factors of 28 and 28 is the multiple of 4 and 7. Therefore, the correct answer is option 3. 28 is the multiple of number 7. Misconception 3. Out of the following, which number is the factor of 96? Due to the confusion in the concepts of factors and multiples, sometimes 192 is mistaken as the factor of 96, which leads to incorrect option 1. The correct way is that we can express 96 as 2 multiplied by 48. Therefore, 48 is the factor of 96. Therefore, the correct answer is option 2. Today we have seen some misconceptions related to the following concepts. Today we will learn about the prime factorization. We see many things around us, like photo frame, water bottle, pen, etc. They are all made up of different parts. It is the same with numbers. Let us consider number 6. It is formed by the multiplication of 2 and 3. Similarly, if we consider number 10, it is formed by the multiplication of 2 and 5. Such numbers whose multiplication gives the number itself are called the factors of that number. Sometimes we need to break a number to find those numbers whose product is the given number. That is, we need to find out the factors of that number. The method of breaking a number to find the factors is called factorization. Let's factorize the number 40. Can you express 40 as a product of two or more numbers? Try it. Upon trying, you must have understood that 40's factorization can be done in different ways, like 2 multiplied by 20, 4 multiplied by 10, 5 multiplied by 8, etc. What does it tell you? We can say that the factorization of a number can be expressed in different ways. 40 has another interesting factorization. 2 multiplied by 2 multiplied by 2 multiplied by 5. Can you tell what its speciality is? You got it right. In this factorization, all are prime factors. This way of expressing a number in prime factors is called the prime factorization. Keep in mind that the factorization of a number is to break that number into smaller numbers. On the other hand, the prime factorization of any number is to break the number in prime factors. Now the question is, how to do the prime factorization? Let's learn an interesting way to do it. Let us assume the number as a tree whose prime factorization has to be done. Just like a tree is divided into branches, in the same manner, we will find a pair of factors whose product will be that number. Similarly, just like the branches of the tree are divided into smaller branches and finally into leaves, we will express the factors into smaller factors. At last, we will reach a stage where leaves cannot be further divided. In the same way, we get into this situation by obtaining small factors where we cannot express any of them to smaller factors. At this stage, we get the prime factors of the given number. Isn't it an interesting method? Another way of doing the prime factorization is the division method. Let's understand it. Let's find out prime factors of 40. First of all, draw all images as shown in the screen. The prime factorization of number 40 has to be done, so we will write it in the second column of the top row. Now, we will choose the smallest prime number which completely divides 40. By applying the divisibility rule of 2, 40 can be completely divided by 2. So, we will write 2 in the first column of the first row. On dividing 40 by 2, the result will be 20. We will write it under 40 in the second row. Again, we will find the smallest prime number which completely divides 20. Since 2 completely divide 20, we will write number 2 in the first column of the second row. 10 is the quotient of 20 by 2. So, we will write it in the second column of third row. In the same manner, we will divide 10 by 2 and write 5 in the second column of next row. Then, we will divide 5 by 5. At the end, we get the number 1. All the number of column 1 are the prime factors of 40. Therefore, we will write 40 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 5. Today we have learned the prime factorization. In the next video, we will learn it in a better way with some examples. Today we will see examples of prime factorization. A puzzle game is going on in a classroom. The teacher has written a puzzle on the blackboard. The puzzle is, I am the smallest number having 3 different prime factors. Tell me, who am I? Ajay's reply is 6, Vijay's reply is 105 and Namrata's reply is 30. In your opinion, who gave the correct answer? Let's read the puzzle once again. I am the smallest number of 3 different prime factors. Tell me, who am I? That means we have to find out the smallest number with 3 different prime factors. Now, to find out the smallest number, the prime factors should be small. But they must be different at the same time. So we will choose 2, 3 and 5. To find out the smallest number, let's multiply them. Therefore, the result of 2 multiplied by 3 multiplied by 5 is 30. So we can say that Namrata gave the correct answer. Next example, find out all the prime factors of 120. Prime factorization is the method of expressing any number into its prime factors. Let's do the prime factorization of number 120. In order to do this, we can choose any method between factor tree or division method. Let's use the factor tree method here. First of all, we will find out the factor pair of 120 whose product is 120. There can be many such pairs like 4 and 30, 8 and 15, 5 and 24, etc. If you feel any difficulty to find the factor pair, then you can use divisibility rule to find it out easily. Please read these rules by stopping the video. Since the end digit of number 120 is 0, this number can be divided by 10. Which means one of the numbers among factor pair of 120 is 10. To find out the second number, we divide 120 by 10. By doing so, we get the second number of the pair, which is 12. As you can see, both 10 and 12 are composite numbers. So, we can express them in their factor pairs and extend factor tree. Can you find their factor pair? Think about it. Let me tell you. 2 and 5 is the factor pair of 10 and 3 and 4 is the factor pair of 12. Since 2, 3 and 5 are prime numbers, they cannot be divided further. Which means the branches of factor tree cannot go further. But number 4 can be definitely divided. The factor pair of this is 2 and 2. Thereafter, the branches cannot be extended. Now we can express 120 as 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 5. In this way, we have found the prime factors of 120. Therefore, to find the prime factors of any number, divide it into the branches until we get all the prime numbers. Next example. Which of the following numbers has both 2 and 3 as prime factors? To find the solution of the given question, we have to do prime factorization of 84 and 105. Let's first do the prime factorization of 84 by division method. In this method, we divide the number with the prime numbers like 2, 3, 5, 7, etc. again and again. The smallest prime number is 2. Since 84 is an even number, it is divided by 2. On dividing 84 by 2, we get 42. On dividing 42 again by 2, the result will be 21. 21 is not divisible by 2, so we will check the divisibility by next prime number 3. Since the sum of the digits of number 21 is 3, which is divisible by 3, therefore 21 is also divisible by 3. On dividing 21 by 3, we get 7. Since 7 is a prime number, we divided it by 7 only. In the last stage, we will get number 1, which shows that we have found out all the prime factors of 84. Therefore, 84 can be expressed in prime factors as 2 multiplied by 2 multiplied by 3 multiplied by 7. Now let's find the prime factorization of 105. In order to do this, let's use factor tree method. So, for 105, we will find a factor pair whose product is 105. 15 and 7 is one such pair. Similarly, factor pair of 15 is 3 and 5. Since there are prime numbers at the end of all branches, we can say that the factor tree of 105 is complete. Therefore, we can express 105 as 3 multiplied by 5 multiplied by 7. As you can see, both the numbers 2 and 3 are the prime factors of 84 only. So the answer of the given question is 84. Today we saw some examples of the prime factorization. In the next video, we are going to see some misconceptions and common mistakes related to it. Today we will see some common misconceptions and mistakes related to prime factorization. Misconception 1. Which factor tree represents the prime factorization of 30? While representing factor tree, sometimes addition operation is used to find the factor pair. Like in option 1, the addition of 10 and 20 is 30. Similarly, the addition of 5 and 5 is 10. This is an incorrect way of representation. The correct way to perform this is to find those numbers whose product gives the same number. Therefore, the correct answer is option 2. Sometimes number 1 is also included in the factor tree. It is important to understand that the factor tree is created to obtain the prime factors. Since 1 is neither a prime number nor a composite number, option 3 is also an incorrect answer. Now let's see some common mistakes related to prime factorization. Sometimes factorization and prime factorization are considered the same. With this wrong understanding, when asked to find the factors of 18, the answer given can be 1, 2, 3, 6, 9 and 18. And when asked to find the prime factors of 18, and the answer given can be 2, 3 and 3. For a clear understanding, it is important to know the difference between factorization and prime factorization. Factors obtained by factorization method can consist of both prime and composite numbers. But the factors obtained by the prime factorization method can only be prime numbers. Today we saw some common misconceptions and mistakes related to prime factorization.
Today, we will learn divisibility rules. We come across many situations in our life where we need to check whether a number is divisible by another number. Without performing the division, we can easily identify whether the number is divisible by another number or not with the help of divisibility rules. Let's learn these rules. Divisibility by 2. If a number has any of the digits 0, 2, 4, 6 or 8 in its ones place, then the number is divisible by 2. This is because if the last digit of the number is 0, 2, 4, 6 or 8, then that number will be even number. And every even number is divisible by 2. Therefore, we can say that for divisibility by 2, the last digit of the number must be even. Divisibility by 3. If the sum of the digits of a number is divisible by 3, then the number is divisible by 3. Divisibility by 4. If the number formed by the last two digits of a number is divisible by 4, then the number is divisible by 4. Divisibility by 5. If a number has either 0 or 5 in its ones place, then the number is divisible by 5. Divisibility by 6. If a number is divisible by both 2 and 3, then the number is also divisible by 6. Let's find out why this rule works. Here, 2 and 3 are co-prime numbers. That means, other than 1, there is no common factor for 2 and 3. If two co-prime numbers completely divide a number, then the product of those two co-prime numbers also divide that number completely. We can simply say that to check the divisibility by a number, we can check the divisibility by its co-prime factors. Divisibility by 8. If the number formed by the last three digits of a number is divisible by 8, then the number is divisible by 8. Divisibility by 9. If the sum of the digits of a number is divisible by 9, then the number is divisible by 9. Divisibility by 10. If a number has 0 in its ones place, then the number is divisible by 10. You can understand this in another way. The co-prime numbers 2 and 5 are factors of 10. If the last digit of a number is 0, then the number is divisible by both 2 and 5. Therefore, that number is also divisible by the product of those two numbers, which is 10. Divisibility by 11. Find the difference between the sum of the digits at odd places and sum of the digits at even places from the right of the number. If the difference is 0 or divisible by 11, then the number is divisible by 11. Let's see some interesting patterns. Do you observe any similarity among the following numbers? Just think about it. Let me tell you. The last digit of all the numbers is even. Therefore, all these numbers are divisible by 2. If we observe the number formed by the last two digits of these numbers, then they are divisible by 4. Therefore, we can say that these numbers are also divisible by 4. Similarly, if we observe the number formed by the last three digits of these numbers, then they are divisible by 8. Therefore, given numbers are divisible by 8 also. Thus, the divisibility of 2 can be checked by considering the last digit. Divisibility by 4 can be checked by considering the last two digits, and the divisibility by 8 can be checked by considering the last three digits of a number. Today, we have learned the divisibility rules. In the next video, we will learn it in a better way with some examples. Thank you. Today, we will see some examples related to divisibility rules. A farmer has 187 fruits to sell. Can you find the minimum number of fruits so that he will be able to divide them equally? From the given example, the total number of fruits is 187. Since the number of fruits in each bag has to be same, we have to find the smallest number that will divide 187 completely. In order to find this, we will use the divisibility rules. The last digit of 187 is 7, which is not among 0, 2, 4, 6 or 8. Therefore, 187 is not divisible by 2. The sum of the digits of 187 is 16. Since 16 is not divisible by 3, 187 is also not divisible by 3. The number formed by the last two digits of 187 is 87. Dividing 87 by 4, the quotient is 21. But we get remainder of 3. Since the number formed by the last two digits of 187 is not divisible by 4, the number 187 is also not divisible by 4. The last digit of 187 is neither 0 nor 5. Therefore, the number 187 is also not divisible by 5. Since the number 187 is neither divisible by 2 nor 3, 187 is also not divisible by 6. We have no rule for the divisibility of 7. Thus, to check the divisibility by 7, we need to divide 187 by 7. By division, we get the quotient 26 and remainder of 5. Therefore, 187 is not divisible by 7. The number formed by the last three digits of 187 is 187 itself. Dividing 187 by 8, the quotient is 23, but we get a remainder of 3. Therefore, 187 is not divisible by 8. The sum of the digits of 187 is 16, which is not divisible by 9. Therefore, 187 is not divisible by 9. The last digit of 187 is not 0. Therefore, 187 is not divisible by 10. Now, let's check the divisibility by 11. In 187, considering from right, 1 and 7 are at odd places and 8 is at even place. The sum of the digits at odd places is 1 plus 7, which is 8. Similarly, the sum of the digits at even places is 8. Since the difference between these two, that is 8 minus 8 is equal to 0, therefore 187 is divisible by 11. Thus, there should be a minimum of 11 fruits in each bag. Next example. Is the following number divisible by 6 and 11? The rule of divisibility by 6 says that if a number is divisible by both 2 and 3, then the number is also divisible by 6. So, for the given number, first we check the divisibility by 2 and 3. Since the last digit of the given number is 6, it is one among 0, 2, 4, 6 or 8. Therefore, this number is divisible by 2. Similarly, the sum of the digits of the given number is 31. Since 31 is not divisible by 3, the given number is also not divisible by 3. Even though the given number is divisible by 2, it is not divisible by 3. Thus, the given number is not divisible by 6. Now, let's check the divisibility by 11. In order to do this, we need to find the sum of the digits at odd places from the right. The digits at odd places are 6, 4, 6, 5 and their sum is 21. Similarly, the digits at even places are 6, 3, 0, 1 and their sum is 10. The difference between these two results is 11, which is divisible by 11. Therefore, the given number is divisible by 11. Today, we saw some examples related to divisibility rules. In the next video, we will clear some misconceptions related to this. Thank you. Today, we will see some common misconceptions and common mistakes related to divisibility rules. First one. Is 1,12,468 divisible by 8? Sometimes, the divisibility of a number by another number is determined by considering only the last digit of that number. Since the last digit of the given number 8, it is considered to be divisible by 8. And option 1 is an incorrect answer. The correct understanding is that there are different rules for divisibility by numbers. The rule of divisibility by 8 is If the number formed by the last 3 digits of a number is divisible by 8, then the number is divisible by 8. The number formed by the last 3 digits of the given number is 468. By dividing this number by 8, we get the quotient 58 and the remainder of 4. So, the number 468 is not divisible by 8. Therefore, the given number is also not divisible by 8. Misconception 2. Which digit comes in the place of A so that the number is divisible by 3? If we put 3 in the place of A, then the number becomes 25,363. Sometimes there is a misunderstanding that since the last digit of the number is 3, the number will be divisible by 3. If we put 2 in the place of A, then the number becomes 25,362, which is an even number. Another misunderstanding is that division of an even number by an odd number is not possible. Because of this misunderstanding, option 2 is considered as wrong and option 1 is chosen, which is incorrect. To check the divisibility by 3, we will substitute 3 in the place of A and find out the sum of the digits. The sum will be 19. Since 19 is not divisible by 3, 25,363 is also not divisible by 3. So, we cannot write 3 in the place of A. Now, we will write 2 in the place of A and find out the sum of the digits. The sum will be 18. Since 18 is divisible by 3, 25,362 is also divisible by 3. That means we have to replace A with 2. So, option 2 is the right answer. Let us now understand some common mistakes related to divisibility rules. Many times, the divisibility rules are known, but if asked to check for divisibility of a larger number, then it is checked by normal division rather than using the rules. Sometimes, there is difficulty in applying the rules correctly. Divisibility rules help check for divisibility. For example, the rule of divisibility by 3 says if the sum of all the digits is divisible by 3, then that number is also divisible by 3. Here, the sum of the digits of the given number is 45, which is divisible by 3. Therefore, this number is divisible by 3. Today, we saw some common misconceptions and mistakes related to divisibility rules. Thank you.
Today, we will learn the highest common factor and the lowest common multiple. Let's first learn about the highest common factor, which is also known as HCF. To understand this, we need to find the factors of 20 and 24. The factors of 20 are 1, 2, 4, 5, 10 and 20. Similarly, can you list the factors of 24? Think about it. You are right. The factors of 24 are 1, 2, 3, 4, 6, 8, 12 and 24. Among the factors of 20 and 24, the factors 1, 2 and 4 are common. We call them common factors of 20 and 24. 4 is the highest number among the common factors of 20 and 24. Therefore, 4 is called the highest common factor. That means, for any two or more given numbers, the highest of their common factor is called highest common factor or HCF. It is also known as the greatest common divisor or GCD. Let's learn to find the HCF of the given numbers. Let's find the HCF of 20 and 24. First, perform the prime factorization of these two numbers. The prime factorization of 20 can be performed in the following way. The obtained factors as 20 is equal to 2 into 2 into 5. Similarly, perform the prime factorization of 24. This would be 24 is equal to 2 into 2 into 2 into 3. Now check for the common factors among the prime factors of these two numbers. As you can see, 2 is repeating twice among the prime factors of 20 and 24. There is no other common factor between the two. Therefore, the HCF of 20 and 24 is 2 into 2 is equal to 4. Let's now learn about lowest common multiple or LCM. To understand this, let's find the multiples of 6 and 8. The multiples of 6 are 6, 12, 18, 24, 30, 36, etc. Similarly, can you tell me the multiples of 8? Think about it. You are right. The multiples of 8 are 8, 16, 24, 32, 40, 48, etc. Among the multiples of 6 and 8, 24, 48, etc. are common. These numbers are called common multiples of 6 and 8. 24 is the lowest number among the common multiples of 6 and 8. Therefore, it is called the lowest common multiple. That means, for any two or more given numbers, the lowest of the common multiples is called the lowest common multiple or LCM. Let's learn how to find the LCM of the given numbers. Let's find the LCM of 6 and 8. First, we perform the prime factorization of these two numbers. The prime factorization of 6 can be performed in the following way. Therefore, we will write the obtained factors as 6 is equal to 2 into 3. Similarly, for 8, we get the factors 2 into 2 into 2. As we can see, the factor 2 is repeated thrice and the factor 3 occurs only once. The product of these prime factors will be the LCM of the given numbers. In order to find the LCM of 6 and 8, we will find the product of the prime factors occurring in maximum numbers. Therefore, the LCM of 6 and 8 is 2 into 2 into 2 into 3, which is equal to 24. There is another interesting method to find LCM. Let's understand this. Let's find the LCM of 6 and 8 by this method. First, we write 6 and 8 in a row with some space in between. Let's find the smallest prime number which will divide at least 1 among 6 and 8. In order to find such a number, we could take the help of divisibility rules. Both 6 and 8 are divisible by 2, so let's divide them by 2. By dividing 6 and 8 by 2, the results are written in the next row. Similarly, we find the smallest prime number which will divide at least 1 among 3 and 4. 2 is the smallest prime number. Since 3 is not divisible by 2, we will write it in the next row as it is. Dividing 4 by 2, the result is written in the next row. In a similar manner, we will divide 2 by 2 and write down the result in the next row, and we will write 3 in the next row as it is. Now, we divide 3 by 3. Now the method came to an end. To find the LCM of 6 and 8, we will multiply these numbers. Therefore, the LCM is 24. Today, we've learnt the highest common factor and the lowest common multiple. In the next video, we will understand it in a better way with some examples. Today, we will look at some examples of HCF and LCM. There are some fruits in this box. Can you find the minimum number of fruits that can be divided into 9, 12, and 15 equal parts? In the given example, we have to find the minimum number of fruits that can be divided into 9, 12, and 15 equal parts. This is possible only when the number of fruits is divisible by 9, 12, or 15. In order to find the minimum number of such fruits, we need to find the LCM of 9, 12, and 15. To do this, we will write these numbers as follows. Now we will find the smallest prime number which will divide at least one of them, that is 2. But 9 cannot be divided by 2, so we will write it in the next row as it is. We will divide 12 by 2 and write the result in the next row. 15 is not divisible by 2, so we write it again as such in the next row. By repeating the process, we will again divide the numbers by 2. We will write 9 and 15 in the next row as it is and divide 6 by 2 and write down the result 3 in the next row. The next smallest prime number to divide them is 3. Because the numbers 9, 3 and 15 is not divisible by 2, we will continue the process till we get 1, 1, 1 in the same row. In order to find the LCM of 9, 12 and 15, multiply these prime numbers to get 180. So, there should be a minimum of 180 fruits in the box. Next example. Harsh loves to solve puzzles. One day, he found a puzzle in a book. Puzzle was, I am a number which divides 324 and leaves 9 as a remainder and divides 470 and leaves 5 as a remainder. He got 15 as the solution. Can you tell whether he's correct or wrong? Let's understand the puzzle first. In the puzzle, the number divides 324 and leaves 9 as a remainder and divides 470 and leaves 5 as a remainder. If we subtract the remainder from dividend, the number obtained is completely divisible by the divisor. This means by subtracting 9 from 324, we get 315, and this is completely divisible by the required number. Similarly, by subtracting 5 from the number 470, the number obtained will be completely divisible by the required number. That means the required number will be the highest factor of both 315 and 465, which we call HCF. Let's find out the HCF of 315 and 465. First, perform the prime factorization of 315. We get 315 is equal to 3 into 3 into 5 into 7. Now perform the prime factorization of 465. We get 465 is equal to 3 into 5 into 31. Both 315 and 465 have 3 and 5 as factors. Hence, the HCF of 315 and 465 is 3 into 5, which is 15. Let's check our answer. If we divide 324 by 15, we get 21 with a remainder of 9, which is correct according to the riddle. Similarly, if we divide 470 by 15, we get 31 and a remainder of 5, which is again correct according to the riddle. Therefore, we can say that Harsh has found the correct answer to the riddle. Today, we saw some examples of the following concepts. In the next video, we will clear some misconceptions related to this. Today, we will see some common misconceptions and mistakes related to the following concepts. Misconception 1. Which of the following numbers is the HCF of 14 and 15? Due to misunderstanding, sometimes the method of LCM is used instead of HCF. The result will be 210, which is an incorrect answer. In order to find out HCF, prime factorization of 14 and 15 is done. Since there is no common factor among the factors of these two numbers, 0 is considered as HCF. This is a misunderstanding. The correct understanding is that 14 and 15 are co-prime numbers. That means, among the factors of these two numbers, 1 is the only common factor. Therefore, HCF of 14 and 15 is 1. So, option 3 is the correct answer. Misconception 2. Which of the following numbers is the LCM of 90 and 84? In order to find the LCM of 90 and 84, many times their prime factors are written correctly, but by mistake, wrong factors are chosen. Since 2 and 3 are common factors for both numbers, those factors are excluded and all other factors are chosen for finding the product. By doing this, option 1 is chosen, which is incorrect. Similarly, sometimes ignoring the factors which occur only once, we choose the factors which occur more than once for finding the product. Hence, option 2 is incorrect. The correct way of choosing the factors is like this. Among the factors of 90 and 84, 2 has occurred a maximum of 2 times. That's why we write 2 into 2. Similarly, 3 has occurred a maximum of 2 times. So, we will multiply them with 2 into 2. Also, 5 and 7 have occurred only once. So, we will place them in the product. Hence, the LCM of 90 and 84 is 1260, which is option 3. Now, let's discuss some common mistakes related to HCF and LCM. Common mistake 1. While representing the factors obtained by prime factorization, sometimes addition or comma signs are used. It is very necessary to understand that while representing the prime factors, multiplication sign must be used. Common mistake 2. Sometimes students think that highest common factor and greatest common divisor, also called GCD, are two different concepts. So when asked to find the greatest common divisor, they get confused. It is very important to understand that the highest common factor and the greatest common divisor are both the same. We can say they only differ by name. Today, we saw some common misconceptions and mistakes related to the following concepts.